This is part 3 of the consciousness map, and we are going to go straight into sleep activation. Sleep activation is initiated by the thalamus in a synchronous burst of activity called sleep spindles, or sometimes spindle bursts. This synchronous activity prepares to shut the body down and move it into sleep. I'll explain how sleep is still part of these states of consciousness and not a separate, altered consciousness as we typically tend to view it. It's still defined by specific neural activity going or activating and deactivating specific parts of the body. So this X here is NREM sleep. The sleep spindles shut your body down and you move into the first stages of NREM. Neither the visual system nor the autonomic nervous system are shut off completely during NREM, which is the first clue that indicates it's not some separate type of consciousness. It's just an extension of all of these different neural activities, all of these different flows of innervation. The parasympathetic nervous system is activated during non-REM sleep. And so one of the ways you help yourself fall asleep is to be in a state of parasympathetic activation. There is a lesser known practice that's usually only referenced in meditative traditions in like the East, but it's the ability to stay awake during NREM. You're essentially able to maintain a level of wakefulness during NREM. Another clue for sleep activation is what we'll call the twilight zone, or twilight. This is the state you're in when you're transitioning to sleep, when you get hypnagogic imagery. These are the drowsy and trippy visuals and auditory illusions that you'll get as your body is getting ready for sleep. You can, however, stay awake through this. You can force yourself to stay awake through the activation of your visual system. By exciting these visual nerves, you can maintain wakefulness during sleep activation. Think of pulling an all-nighter or even waking up in the middle of the night and you're in this sort of half sleep, half awake state. That's the twilight state here. Now, before we move on, it's worth noting the role that audio signals play in all of this. And that again has to do with the visual system. Audio signals and visual signals, they like to synchronize in the brain. This is why listening to music helps you get into focused or trance states, or it could even help you calm down if you're trying to somatically reassociate. Or if you're in a trance, or even further, you'll start to get hallucinations, and this can include audio hallucinations. So being in this same state of sleep activation, when the sympathetic nervous system is activated, we can call this hallucination. Think about how you may be overstimulated in a frantic state. If that continues to progress, you go beyond the trance into sleep activation, and that's when you start to hear things. You think you're hearing your name, or you hear words or whispers or sounds, and you also start to hear stuff. Because audio signals and visual signals, they like to synchronize in the brain, so one may affect the other, one may cause the other, but that doesn't necessarily mean both are happening at the same time, just that they can synchronize like that. And again, it's why music, especially for people that are working out and trying to get themselves into a sort of rage state in order to lift heavier weights, music is such an important role in building that trance state. Or you may listen to music that helps you fall asleep. In the same sense, it's putting you in a trance and getting you into sleep activation, which will then put you into NREM. After the NREM states, you go into your REM cycles, your REM sleep. The sympathetic nervous system starts to activate during REM sleep. And REM sleep, as we know, is when you start to have dreams, and the sympathetic nervous system is activated for that. If you're in a balanced enough state during REM sleep, during sleep activation, you can have a lucid dream. Lucid dreams are the part of your brain that deals with conscious attention is awake, is activated. It's kind of like the flow state or psychosis state version of dreaming. But similarly, if you're awake and you're in psychosis or dissociating and sleep activation happens, with enough sympathetic activity, you can have something similar to hallucinations depending on the level of autonomic activation. It's integrating a lot of subconscious information that's usually repressed until sleep, but now you're getting that while you are awake. But again, sleep and wakefulness is just certain levels of neural activity activating or deactivating certain parts of the brain that can be forced to stay active. When you're in sleep activation and you're in a trauma survival situation with the sympathetic nervous system activated, you can have night terrors or paralysis or being in a catatonic state. Sleep paralysis, alien abduction stories, catatonic states, nightmares. This is full activation in trauma survival situations of the sympathetic nervous system during sleep activation. So you could be sleeping and dreaming, and suddenly your sympathetic nervous system is activated to its full extent in having night terrors or sleep paralysis or catatonic states. So even from frantic or berserker states, you can freeze up with sleep activation and become catatonic. So how does this work? How are you able to stay awake even through sleep activation? How are you able to keep yourself from shutting down in its normal sleep state? The mechanism behind this has to do with the layout of the thalamus. Visual signals actually pass through the thalamus to gain conscious attention in the visual cortex. If enough visual signals are dampening out pain signals long enough, the thalamus responds thinking that it's ready for sleep. The thalamus then responds by sending the spindle bursts. However, these bursts can be asynchronous if you're not actually prepared for sleep. This means that the normal activation of sleep is being initiated, but because the bursts are asynchronous, it doesn't shut the body down, which means you're able to stay awake during sleep activation. And so these states apply to whether or not you're actually sleeping or you're awake, because those two aren't such separate types of consciousness. They're just whether or not certain parts of your brain and body are shut down. But the autonomic nervous system and the visual system, they stay active and they stay awake and they stay fluctuating even while you're asleep, suggesting that the two states aren't so different in terms of altered states of consciousness, but part of the same map of nerve control or innervation flow. And this is why it progresses from trance. The dampening of nociceptive signals, of pain signals, eventually leads to sleep activation. And it's the same dampening of pain signals that gives these states such a powerful numbing effect. If the trance is either maintained for too long or the intensity of the visual signals increase, that's when you start to cause hallucinations. You start to integrate sleep activation into your wakefulness. The twilight zone here, and night terrors, catatonic states, hallucination, and lucid dreams. The wakefulness aspect of this point here you could think of as kind of being able to control the hallucination or the sense of being kind of in between worlds that is associated with dreaming and sleeping, of hypnagogic activity. In part 4, we'll finally get to the ecstatic states, the seizure states here at the top, at the highest level of visual innervation. But just to give kind of a quick overview, you can see the different rising, the excitability, the flow of nerves from one state to the next, from the autonomic nervous system and the visual systems here. So this model here is meant to be a reference map, and I've tried naming them in ways that kind of are consistently themed together. I just study a lot of military and shamanic practices, so the language may be a little more catered to that, which you'll see more so when we get to the ecstatic states up here. As always, I'll keep explaining more and try to go back and simplify it after the parts, but thanks for watching.